Hello, good afternoon, everyone. This is Kira Zeidelman with the NARUC Center for Partnerships and Innovation. I would like to introduce our moderator today, Megan Levy from the Wisconsin Office of Energy Innovation. Megan, take it away.
All right, thanks a lot, Kira. And thanks so much to NARUC and NASEO and the whole working group for allowing me to moderate this really interesting session today about utility microgrid procurement. I know that a lot of the folks who are in the working group, a lot of the states that I've spoken with, have been investigating microgrids for a variety of reasons over the past even 10 years with some of the states who have really been out in front. Wisconsin has taken a more cautious approach, and we are just dipping our toe into this pool, which is why this working group is so valuable for us to learn from all of the things that our partners across the country have already done. And really our take on this is more about utility, or about microgrids for procurement, or for resilience, I should say. Because we're looking at critical infrastructure. Well, take, for example, the derecho that hit Iowa on August 10th, where we had almost 500,000 people out of power, and they were out of power for up to 5 days. So defining what critical infrastructure is sort of our first challenge as we move into a little grant program that will be rolling out early next year, critical infrastructure microgrid for community resilience grant program. And I think we're going to learn a lot about the type of ownership models that make sense for microgrids as we move forward. And there's been just a ton of work done on this. We're going to hear from a couple of utility representatives who I think will be able to help us learn a lot more about, first of all, the Bronzeville community microgrid, which we've heard about previously in our first in-person meeting back in February. We'll have Aleksi, Paaso, the Director of Distribution Planning, Smart Grid and Innovation for Commonwealth Edison, speaking. And then we'll also have Matthew Schultz, the Business Development Manager for Duke Energy. And they're both going to give us their perspectives on microgrid procurement from the utility side. And I'd just like to say, for all the states on the line, we're watching you, we're looking at your programs. I mean, Rhode Island, New York, New Jersey, California, Maryland, Massachusetts, Connecticut have all launched various microgrid feasibility studies, critical infrastructure, grant programs, prizes, competitions. So we know that there's a lot to this. And there's a lot to designing the microgrid that is really the resilient setup that can give you that support for mission critical functionality. So without further ado, and I do want to say we unfortunately lost a speaker from PG&E who was supposed to be here, but due to the wildfires and things that are going on in California right now, he could not be with us. But before we get started, before I launch this, I want to remind everyone, because I'm sure you've been on 875 webinars since March, but you can submit questions 2 ways. You can raise your hand, or our champion, Kirsten Verklaas, will be monitoring the chat. So feel free to type a question in there. If you don't want to go ahead and verbally speak your question, go ahead and type it into the chat box. But if you raise your hand, I'll take a look and call on you to unmute your line, and we can have a discussion. So we'll have a little more extra time today for discussion and for our presentations. So I encourage you all to get your questions ready. And with that, I'm going to hand it right over to Aleksi Paaso, the Director of Distribution Planning, Smart Grid and Innovation for Commonwealth Edison. Thanks, Aleksi.
Hey, good afternoon, and thank you. So good afternoon, everybody. I'm very excited to be here this afternoon to talk about the ComEd's industry-leading Bronzeville Community Microgrid project. So I'm going to go over a few different things, starting from the drivers for the microgrid deployment, our approach to select the sites for microgrid, as well as give you a little bit of a status update in terms of where we're at with the project. Today, what we have learned so far, and how does that fit into also as part of our broader community of the future vision. So if you could go to the next slide. So just before we go into the microgrid discussion, a little bit of background about the ComEd. ComEd is part of the Exelon family of companies amongst the 6 utilities. The other 5 are in the East Coast, in the Maryland, Delaware, and DC, and New Jersey region, and ComEd here in Northern Illinois, where we serve about 4.1 million customers. That includes rural, suburban, and urban regions, including the city of Chicago. Our peak load was measured in 2011, just under 24 gigawatts, and we haven't seen quite that high loading since, due to the number of items mentioning the energy efficiency, but also the local economic conditions as well. As far as our system stats, we have about 500,000 distribution transformers, over 70,000 miles of primary distribution, and about 6,000 transmission miles. ComEd also has a second largest network grid in the US after the ComEd grid in New York. So if we could move to the next slide, really the challenges of the planning and operating the grid are changing. The need for resiliency is more apparent now than ever. And we're seeing a number of weather events increasing, both in terms of the quantity, but also in terms of their impact. And as it was mentioned, just last week we saw the echo in our service territory with over 90-mile-an-hour winds and 13 confirmed tornadoes impacting our regions. So events like this require us to focus on the system planning and consider new technologies like the microgrids to help mitigate the impacts of those technologies or those events, but also enabling the grid to come back quickly from those initial impacts. So if we move to the next slide, I'd like to start on a little bit on the background how we selected Bronzeville for the microgrid deployment at ComEd. So microgrids have been determined and examined, like it was mentioned, for quite a while, and determined by experts that they have a capability to enhance resiliency to the specific areas. So really for us, it was what we were installing, but also where in the system where that microgrids would make most sense. So we developed a holistic data-driven methodology where we determined different capacities of the grid. So we looked at the power delivery infrastructure that in each areas, the existing critical infrastructure, and then we also took feedback from the external emergency management stakeholders in terms of what areas and what capabilities would be those that microgrids could provide most value to. So we looked at this, the holistic service territory sense, and split our territory into these 1 mile by 1 mile sections, and even smaller sections within the highly urban region in the city. And we considered the data in this highly granular fashion in order to determine which areas would be the ones that could benefit most from this initial microgrid deployment. And out of this study, the Bronzeville community emerged, and Bronzeville is just a few miles south of the central business district in Chicago. So if we move to the next slide, so the Roswell Microwave project is really deployed primarily to offer higher levels of resiliency and also demonstrate innovation that are going to drive sustainability and more of the distributed approach to the grid operation for the future. Once we have both phases of the project completed, the microgrid will serve about 1,000 residences, businesses, and public institutions, including 11 customers that were determined to provide critical public service. And amongst those customers is, for example, the City of Chicago Police Headquarters. The project was designed to be deployed in 2 phases, and the first phase included the installation of solar PV, about 750 kW of that, and then half a megawatt, 2 megawatt hour energy storage system. That was all completed as of 2019, and we demonstrated the capability of the microgrid through islanding testing. We're currently working on the second phase of the project, which includes expanding the boundaries to the full footprint, as well as deploying controllable distributed energy resources to serve the microgrid. So if we move to the next slide, I'd like to highlight some of the things that the microgrid is able to do. So we see the microgrid here as a platform to demonstrate other emerging technologies as well, in order to meet the challenges and provide higher levels of service in the future. So there are a variety of different solutions and technologies that utilize the microgrid as a platform. For example, we're testing advanced sensors to provide higher levels of observability, and we have developed a microgrid master controller that can operate not just one microgrid, but microgrids as a clusters. Really being able to demonstrate various technologies is key in terms of learning about their impacts, and we can now do it in a controlled way in this highly distributed system that we have in Bronzeville. So if we move to the next slide, I'd like to just highlight a couple of the installations. So the solar installation was deployed at the Chicago Housing Authority buildings within the Roswell neighborhood. So we have solar panels in total of 17 buildings, the roof, and we also have some ground-mounted solar that supports the system. That's combined with the battery energy storage technology that also deploys within the microgrid footprint. And together with the advanced control algorithms and smart inverters, both of these technologies work together as a controllable system. And that's the capabilities that we tested and demonstrated as part of the project last year. This was also the key part of our partnership with the Department of Energy, where we were able to get a significant funding in order to support this technology demonstration that's part of the Bronzeville project. So if we move to the next slide, I'd like to highlight a couple more technologies that we are looking at. And as I mentioned about the system being a platform for broader technology demonstration, we are using advanced sensors such as facial measurement units to provide higher levels of situational awareness. And one of the significant technologies that the PMUs or facial measurement units enable is a distribution state estimator. And that enables us to look at and estimate the real state basically in real time of the system. And why this is important is that when you have a future grid that's expected to be very distributed, very granular in terms of control, having that level of visibility and real-time visibility is very important in order to operate the system the most safe and reliable way as possible. So let's move on to the next slide, and I'll highlight some of the learnings so far. So we utilized a innovative approach for the generation of the microgrid. So rather than procuring a generation, we are procuring the generation capacity as a distribution capacity. So it's a capacity that's available to support the microgrid operations. We're basically applying that same concept both for the solar and also for the controllable generation that we're installing in phase 2 of the microgrid. And with that, we were able to get this very innovative project of the solar that was installed for the Chicago Housing Authority buildings, and that partnership has been has been great in terms of the project learnings. We also deployed the battery, which was the key demonstration objectives of our DOE-funded effort, and we performed various different testing in order to verify the different functionalities of the battery systems. We also evaluated the performance in accordance to performance metrics to ensure that we meet the DOE's goals for the technology. We've also been able to demonstrate the technology in our Advanced Grid Integration and Technology Lab, where it has allowed us to try different configuration, different settings, and different contingencies to evaluate the performance when something unexpected would happen to the system. We also demonstrated the microgrid's ability with a successful islanding testing in 2019, utilizing the batteries, the PV, and also a mobile generator that we deployed temporarily to that location. We also provided a list and evaluated the system performance in accordance with performance metrics to show how the microgrid project provides value both to residential and commercial and industrial customers within the microgrid, but also in the surrounding population. We're now in the process of measuring more than 50 metrics to populate the benefit cost analysis. So if we move to this slide, I wanted to highlight a couple of the key partnerships that we have established and are working on in order to further evaluate and measure the impact of resiliency, which is really the key driver for many microgrid deployments. So through our partnership with Lawrence Berkeley National Lab, for example, we're gauging the direct and indirect economic impact of the metrics for power disruptions in various situations, the geographic settings, and various durations. And we're able to prepare our system by testing hypothetical power interruption scenarios and considering the effects, what would happen with this additional resiliency capability that microgrids provide. We're also working with the National Center for Disaster Preparedness at Columbia University in terms of conducting a tabletop exercise, how different customers can utilize the microgrid technology to mitigate effects of some of those weather events, and how they can best utilize, or how can we rather best utilize the microgrid technology together with our customers. So if we move to the last slide here, I just wanted to highlight how the microgrid comes together and how it plays into a part of our larger vision of our Community of the Future project program. So along with the microgrid project, we are also deploying a wide range of different programs, ranging from STEM programs to off-the-grid renewable energy power streetlights. And within all of these pilots are being demonstrated within our what we call a Community of the Future program. And with this, we're deploying them in a specific area, and not just evaluating one technology by technology, but rather their broader impact as a whole set of different technologies and how they can help different communities by providing value and in terms of their interoperability in order to enhance the sustainability, resiliency, and connectedness of the community. So that's all I had. Thank you.
All right, thank you so much, Aleksi. Wow, that was really, really interesting. The communities of the future. Do we have any questions from the audience? Kirsten, did you see anything in the chat?
Yes, actually, I do have a question. the question is that in island mode, what loads can be covered and for how long? What are the critical loads are covered, and are those all in the public housing complex?
No, so the intention and for the phase 2 is that we are able to carry the full loading of the microgrid by utilizing the control capabilities as well as the generation and the battery energy storage system within the microgrid. So there is no load prioritization, but it's rather it is the full footprint.
And did you mention how long you could sustain all loads in island mode?
Yeah, it's the design that we're going with is that we can support them as long as needed. So as long as there is a natural gas supply in addition to a battery and solar generation, we're able to support the microgrid loading.
Okay, as long as there's natural gas. Got it.
Yeah.
So it's an unlikely scenario.
Yeah, natural gas or other fuels that the generation would utilize.
Gotcha. Well, as an energy security professional, one of the things that we do is just think about the worst case scenario all the time. So I know my colleague Ben Bolton from Tennessee has me thinking about the New Madrid fault and the impact on our natural gas infrastructure in the north. But that's kind of a once every maybe 150 years thing that might not do it. But that's very interesting. Thank you so much for your presentation. Are there any other questions? I don't see any hands raised, but I don't know if I can see the hands. Perhaps Kirsten or Kira can see the hands.
Yes, I just checked. There are no hands raised, but I do have another question. Actually, a couple more questions. So the first one is, in the procurement, did ComEd negotiate the ability to manage and control the inverters on the distributed energy resources, and are you able to share the kilowatt per hour rate?
I'm not sure I got the second part of the question, but let me take a stab at the first one. So yes, for the microgrid purposes, we would have the control of the inverters, and in order to drive basically the generation and also provide real and reactive power for the operation, as long as it's required to preserve the reliability of the system.
I guess the second part of the question was if you were able to share the rate, the kilowatt hour rate.
Could you clarify? So maybe not sure.
I'll ask the person who sent in the question to clarify. In the meantime, he just clarified. Basically he's asking what is the price of energy?
Yeah, the price of energy for the microgrid participants, it's the same as for other customers. So this is considered a demonstration project. So there is no specific microgrid customer rate under this project.
And if I could follow up on that real quick, Aleksi, that's very interesting. It's something that in Wisconsin, as we floated this plan that has a critical infrastructure microgrid grant program in it, one of our commissioners was very concerned about cost and about the impact on ratepayers that microgrids might have if they weren't sort of designed to be equitable to all ratepayers. Can you talk about beyond the pilot phase what you see in terms of the impact of putting forward projects like this?
Yeah, that's really the key learning objective for our demonstration is the ability to capture those full values of resiliency. So we're currently working through that process, and that was one of the big items for us as part of the overall project in order to understand those full benefits. informs not just for Illinois, but also for other jurisdictions in terms of how and where microgrids could provide value. But that's something that's still currently being worked on as we're evaluating the microgrid's performance across different types of events. And once we have it the phase 2 fully deployed, we will see it in effect once some of those events would arise.
Well, great. We'll certainly be watching your progress and looking forward to checking in with you on that and other issues. I guess last call for questions before we move on.
Yeah, I have a couple more. Again, also looking at this financing issue, the question is, was there any other public funding source used for the project? And then a second question, touching again on the natural gas issue, does this mean without natural gas, the microgrid can't support all load?
Yeah, so on the funding side, so we were able to get a significant $4 million funding from the Department of Energy for this project. So that has been the primary source of the public funding. And then on the second one is that it's a highly resilient grid design. So it has the connections to different substations along with the generation within. So its ability to power it is based on that resilient system design, where you have multiple sources, but as well and the generation within.
Okay, thank you. That's all the questions I have.
Okay, great. Well, thanks again to Aleksi, Paaso for that great presentation. I know I found it very interesting and you had a lot of good questions. So we'll move on to our colleague Matthew Schultz from Duke Energy. Take it away, Matthew.
Thank you. Good afternoon, everyone. This is Matt Schultz with Duke Energy. So I've been working for about 2.5 years now in our regulated energy storage and microgrid business development group, where we kind of look to identify kind of battery storage and potential microgrid projects throughout all our regulated service territories. It's been about 10 years now, but in another lifetime, I was staff at the Maryland Public Service Commission for about 3 years. So I have been on the other side of the table, kind of thinking more from a neutral policy perspective and trying to figure out the best way to provide service from customers, not from the utility perspective. So hopefully we can get some good questions later on. We go to the next slide. Yeah, so if you're not familiar with Duke Energy, we are one of the largest regulated utility companies in the country. So we're operating in Indiana, Ohio, Kentucky, North Carolina, South Carolina, and Florida. And we really have plans for battery storage in most of these states. And a large proportion of our battery storage projects do function as microgrids. And then when we say microgrids, what we essentially mean by that is that we're able to operate in island mode, disconnected from the grid. So we have a number of projects. So most of the projects you see here are kind of in the late development stage, so they're public, so they're operational, under commissioning, or about ready to begin construction. So we have large plans for storage in all of our service territories. Next slide, please. So the focus of our storage development and microgrid development really depends, on the state. In the Carolinas, we've had some success in mountainous terrain where some traditional projects can be pretty expensive. We're also looking at mixing generation values. We have a lot of solar there. However, we also have a large amount of existing pumped hydro that kind of captures some of the storage value you might typically expect to see in an environment where you have a large amount of solar generation. We're also not in the market there, which provides some challenges for valuing ancillary services and other generation benefits that storage can provide. Similar in Florida, except we're having, you have hurricane risk driving some needs for resiliency, and you also have more capes and islands that could be good locations for microgrid. And then we have kind of moving to our Midwest territory, we're inside markets in Indiana, Kentucky, vertically integrated. And so we're looking at, some long rural feeders that could benefit from microgrids. And then you can pair that with typically frequency regulation in MISO or PJM, but also some other ancillary benefits that can serve to stack values for the microgrid project as well. And then in Ohio, we're a distribution utility inside of PJM. So there, you really focus on the distribution value. We do have some long rural feeders that could be good for projects. And then there's potential for market participation if it's authorized by the commission potentially in the future. Next slide, please. Yeah, so what do we look for at microgrids? Why do we develop these projects? I think most of the time the standard distribution solutions are going to be the most cost-effective way to improve customer reliability. So it could be hardening the line, it could be having a redundant feeder and sectionalizing the line where possible. So there's a lot of ways the utility can improve reliability. And most of the time that's going to be your most cost-effective solution. So when we're looking at microgrids, it's typically two reasons. First being kind of your unique geographic features. So the long isolated radial line, you've got an isolated town. The line runs for 10 miles. At the end of it, there's a town. There's really no other way to improve the reliability if you have an outage along that radial line other than a microgrid. I think mountainous terrain is another one where it can be really expensive to upgrade, build lines, build second lines. It may be better to, if you have that isolated load pocket, a small town that you want to island to locate some batteries and or a generation source at that town rather than trying to harden the line or build a second line in difficult terrain. And then similar logic for capes and islands. If you've got an underground distribution line, underwater distribution line, that would be very expensive to upgrade, replace, or build a second one of. Then a microgrid could be a really good solution there. And the other area that we've been focusing on is critical infrastructure. So we have one project already partnered with the military, I'll be discussing later. And then we've potentially been looking at hurricane shelters, fire and police station. I think critical infrastructure is a great use case. The challenge is a lot of times they already have kind of your typical backup diesel generation, so it's a bit of a balance to find what's critical, what would be a great place to add reliability that doesn't kind of necessarily already have that existing backup power application. And then the other step is we're really trying to maximize the value for these projects. So if you're sitting out there with a with a battery that may only need to be used a couple of times a year, how can you stack value and use that battery other times when it's not needed for reliability? So typically this would be an ancillary services application. But it could potentially be a little bit of generation capacity, as well if it's needed to provide some additional value. So we're looking to grab all the value that we can while still maintaining the reliability. Next slide, please. Yeah, so this is our first regulated microgrid project. This is the Mount Sterling microgrid, and one of the interesting things about this project is it's actually a true microgrid in the sense that it's no longer even connected to our power grid. It's kind of the perfect storm or perfect scenario. We literally have a communications tower in a national park at the top of a mountain that was connected to our distribution system. Really a couple of kilowatts of load. That distribution line had a lot of outages. It wasn't particularly reliable, and it was coming to the end of its life. So we kind of figured out that there had to be a better solution there. So next slide, please. Yeah, so what we ended up doing was the Mount Sterling solar and storage microgrid. So it's a relatively small project, 10 kilowatt. So solar, but with 95 kilowatt hours of battery, and it was really sized to be able to provide power to the communications tower with no sun for about 2 weeks. And it's just been the product's been operational. We haven't had too many issues. We have, and the great thing about it is we actually were able to kind of give some of the land back to the national park and essentially remove the distribution line. So it's there kind of as a true island, just solar and battery to provide that power to that communications tower out there. So it's been a great project. It's it really it actually, the economics were able to stand up on its own, this being kind of the cost-effective long-term solution for this area. So it's kind of the vision of the future potentially, but a really special use case where you're really talking about a couple of kilowatts load at the top of a mountain, not a town, not a city, etc. Next slide, please. So this is kind of a bigger version of the Mount Sterling project. We had the town of Hot Springs at the only end of a long feeder 10 miles from the substation. We didn't have any other connections nearby, so any outage around a heavily forested mountain along those 10 miles is going to take the entire town down. There really wasn't much we could do to bring another feeder. It would be extremely expensive. So we looked for a microgrid solution to solve the challenge here. Next slide, please. Yeah, so this project is kind of in the commissioning phase currently. So it's 2 megawatts of solar, 4 megawatt hour battery. So it's really a grown-up version of the previous project, and it's there to provide power to the entire town if there's an outage. And when it's not needed for a microgrid, the energy is there, and we'll use it potentially for some ancillary services or potentially for generation capacity in peaking hours. And it was part of kind of a broader regional effort in Western Carolinas to reduce reliance on fossil fuels and develop new technologies. So it's been a very popular project, and I think it should be operational definitely before the end of the year. So it's a good example of where microgrid can play a really improve reliability and be a popular project for customers. Next slide, please. Yeah, so this is more of a critical infrastructure project. This is our Camp Atterbury project in Indiana. This is another one where I believe it's operational in parallel mode currently, where it's non-islanding and it's under commissioning for island mode currently. So we have, essentially it's in Indiana. It's located next to the Camp Atterbury National Guard base. It's a 4.75 megawatt DC solar project with a 5 megawatt lithium ion battery. And essentially it's there. The power is going to go to the grid to MISO. The battery will likely participate in frequency regulation in MISO when operating in parallel mode. And then in the event of a grid outage, it'll be able to provide backup power to some critical loads on the military base there. So again, I think it's in final commissioning right now on the islanding, but I believe it is operational in parallel mode currently. I think kind of going into some of the technical issues. I think on the islanding piece, we found that the solar and battery technology works well. Where we've run into challenges is really our grid is not based around kind of inverter-based microgrids. It's really based around rotational equipment and the protections and control schemes that are there. So where we've run into some challenges for these pilot projects is how does the microgrid interact with the rest of the grid? What are the protections and the control schemes and the communications and the monitoring? I think those have been kind of the biggest challenges. Not can the microgrid work? The answer to that is generally yes, but how it interacts with the rest of the grid and protections and control schemes that are in place is where we've had by far the most learning so far with these projects. Next slide, please. Yeah, so wanted to cover maybe some regulatory challenges with microgrid development that we've seen. So I think when you're looking at distribution only utilities, there's always in a number of states it's kind of a question of the stack value provides the most benefit when you're talking about microgrids and non-wireless alternatives. But it's a question of, well, should distribution utilities own the batteries and participate in the markets, or should kind of third parties own the batteries and participate in the markets while also potentially providing some distribution functions? I think clarity and certainty around that it's helpful. I'm obviously a proponent of utilities owning it. I think when you have a reliability function that customers are depending on, I think you want a utility that's accountable for that, and an entity that the commission is accountable for. But that's certainly coming from a utility perspective. Others will tell you things differently. When we talk about microgrids, a big what we're looking to do typically is improve the reliability. So how do you, we don't typically have standard metrics to value the reliability that's coming from that in order to kind of build out a risk cost benefit analysis. So thinking about how to value reliability and when a microgrid is justified and when it's not is something that's there. And then also kind of, I think, more on the resiliency and critical infrastructure space. It can be hard to quantify the extra value there as well to having having a hurricane shelter that has a secondary power source, et cetera. It can be difficult to do cost benefit analysis. Interconnection rules are another one. When we're developing our microgrid assets, they're typically distribution tied. They're really almost core distribution assets, but the interconnection process is geared toward generators. So we may have a battery that that needs to be have a 5 MVA inverter, so it can produce 5 megawatts of power to back up the load that's needed. But you may not always be able to charge or discharge the batteries at 5 megawatts when it's grid tied. And your typical generation approach to interconnection says, okay, you need to do a line upgrade now. And that's obviously not the right solution when you're trying to operate a microgrid in island mode, and you're not going to be charging the battery up when the line is close to its peak demand, creating issues. And you have that level of granular control, but the interconnection rules aren't written with that in mind. So I think there's a lot of challenges around getting the rules right, allowing to maximize the benefits of the technology while still keeping a level playing field for all parties, which the interconnection rules and processes are very rightly focused on. So that's a big area that needs some reform to accommodate microgrids and storage when we're talking about interconnecting generation. I think the other thing is just thinking about the approval process for new technologies and utilities. A lot of commissions want utilities to innovate and participate with new technologies, and Duke, we're definitely excited to do that, but frequently it's quite frankly a lot of extra work. So there needs to be oversight, obviously, in place. But if you want utilities to experiment, I think it'd be good to proactively figure out a way for them to do that doesn't create a much larger regulatory burden than would be in place for existing technologies, or a way to report out, get have feedback, but not necessarily have an overly burdensome kind of contentious process. I think for some of the projects that that we reviewed, it may have just been easier for us to build a secondary feed, even if it wasn't the most economic, because it's less likely to get a lot of scrutiny, take a lot of legal time, take a lot of kind of internal hours to get approved and justify the business case and get it done. So for providing some limited runway for utilities to kind of test out new technologies and get the learnings that they need to do with requiring a little bit less internal bandwidth, I think that help drive innovation in general, while keeping the appropriate oversight and keeping it appropriately sized before you start talking about really large dollar amounts that are going to drive rates for customers. And then I think the last piece, I think was touched on some of the questions here, is just, do these projects go into rates? For most of the ones we talked about, for you're looking at a communications tower, you're looking for backing up the town, I think that makes sense for them to go into rates. When you start talking about backing up a single customer like a Camp Atterbury, is that does that go into rates? Is that a customer program? When is it appropriate to do that? And should customer, specific customer be paying for it? Do all customers benefit? If a hurricane shelter is more reliable, or a 911 call center is more reliable, et cetera. I think those are some tough challenges, and then it's hard for utilities to to move forward and get programs and get projects in place when there's a lot of uncertainty around that. So I just think that's definitely an area where some more thought and some more work needs to be done to figure out microgrids and when they should be customer programs versus when they should be in rates. That's all I had right now, so happy to answer any questions folks have.
Okay, well, thanks a lot, Matt. Really appreciate that presentation. You brought up a lot of interesting and salient points. Kirsten, do we have anything in the chat or any hands up?
Yeah, we actually have a hand raised by Ben Bolton. So Ben, I'm just going to unmute you.
All right.
And I think you're still self-muted. Ben, I unmuted you. Oh, you said it was just by accident, so no question right now. I do have, I think you touched on this already, Matt, but there was a question on the Camp Atterbury project, if that was project rate-based and who gets the revenue from the MISO frequency regulation service.
Yeah, that project is rate-based, and all the revenues from frequency regulation are going to flow back to customers through rates. So you've got the frequency regulation, the value of the generation is all going to go to the customers, and the base really only benefits when there's an outage on that circuit, and the batteries and the solar wouldn't be able to participate in the markets at all. And when you're in that case, you're providing support to the base. So it was viewed as a pilot project and viewed as kind of a general good for adding resiliency to the military base, but the benefits of the market participation, the battery and the energy are flowing back to all customers and rates.
Great, thank you. And kind of as a follow-up, how does a project serving one customer get to be rate?
Well, the project's not really serving one customer. It's grid tied, so it's only serving one customer when there's a grid outage. So the bulk of the time, the benefits of the project are going to everybody essentially, or as generation assets more or less, and then only when it operates in island mode would it be benefiting the military base. So I think part of it is viewed as pilot and as a pilot project, and learnings. Part of it is increasing resiliency for the military was viewed kind of generally as a public good, and then having that most of the time it benefiting all customers was the justification as well.
Okay, thank you. I think this is a question for both speakers. Do you have any recommendations for overcoming technological approval challenges?
Could there be more specific? What do you mean by technological approval?
Let me unmute the person to ask the question. 1 second.
Can you hear me now?
Yep, you're unmuted.
So you had mentioned the issue of commissions approving processes for new technologies and applications. So the issue is, do you have any recommendations regarding that? Are there some level of pilot that public service commissions might go for? Is there also there's also this notion of the regulatory sandbox to allow some degree of experimentation with either new technologies or approaches or business approaches?
Yeah, so I think the most successful, from our perspective, the most straightforward, process that we've had, and you came out of a settlement agreement in Florida. We essentially were able to get a 50 megawatt pilot program, and a cost cap was put into place for that project. And then we were really able to focus, on finding the best projects and going through a wide variety of use cases, and then we're going to have reporting processes on that. So I think a pilot program appropriately sized for the utility that's not going to be burdensome on the rest of rates with some cost controls, and then you're going to have your reporting requirements that show the learning, show the value, on the back end. I think that's that's a very effective way to do it. There could be other ways as well, but that was one that that we liked, and it came out of a kind of a broader settlement negotiation. And it's obviously something the utility likes, but it can be a lot of work to do something new inside of a regulated utility, internally and externally. So that anything that gives you a clear path helps.
Thank you.
Any other questions for our speakers?
No, those are all the questions I have. Just double checking if there are more hands raised, but I don't see any.
Okay, great. Yeah, I had a question about that Camp Atterbury project as well. Just how long will the batteries last? And is there a natural gas component there as well? Is there some CHP or something?
There is no natural gas component for that project. So it's all solar and natural. Sorry, it's all solar and battery. So the amount of time that'll be able to provide backup power is variable. I don't know the specifics on that site, but I would say kind of our general rule of thumb is we typically size projects for about to be able to provide 4 hours at least backup power, which is going to cover the vast majority of your typical utility outages, and that's obviously going to vary based on, because of the solar component as well, the solar output that is there. So the sizing is a big deal. Was there a second part of that question?
Okay.
I missed it.
Thank you.
Okay.
No, I think that's responsive, yeah. Well, I guess I'll put out one last call for any questions or hands raised before we thank our speakers. And I think here we're going to move into our working group portion directly after this. So I'll just thank everyone for coming, and thank you, Aleksi and Matt, so much. This was very, very interesting.
Yeah, thank you, Megan. So at this point, we will ask anyone who's not a member of the state working group to exit the webinar. We're going to have a brief members only